Academy. Today we're going to have a review, a look at fertilizers. We're going to study fertilizers. We're going to look at sulfur, where we get sulfur from. Remember, sulfur is a non-metal. Where we get sulfur from, and we're also going to look at sulfur dioxide. Okay, so we're going to look at this subheadings. We're going to start with fertilizers. Now, fertilizers. Okay, for fertilizers, we're going to look at first of all, why do we need fertilizers? Or what are fertilizers? Okay, what are fertilizers? A fertilizer is a substance that is being added to the soil to make it more fertile. Okay, a fertilizer is a substance, we say it's a substance that is added to soil to make the soil more fertile, to make the soil, to replenish the soil. Okay, a substance that is added to soil to make the soil perform better, to make the soil regain the nutrients it has lost. Okay, a substance added to soil to improve the soil condition. So there are many words you can use. Added to soil to improve its condition. Added to soil to improve the soil's nutrients. You can say that. To improve soil's nutrient, to soil to improve or to make it more fertile, to make it more fertile, to make the soil more fertile, to make it more replenished, to add nutrients to the soil, to make the soil perform better, to make crops to be able to grow on the soil. So there are many ways to say it. Okay, to make more soil to be able to grow properly, to replenish the lost nutrient, to make the soil regain some nutrients like nitrogen and phosphorus and potassium and so on and so forth. Okay, so you can say all of this. Some nitrate to make the soil get some nitrate, to make the soil get some sulfate, to improve the soil's condition, to make the soil suitable for growing our crops, and to replenish the soils and cover deposits and so on and so forth. So this is what fertilizer is. Now, since we know what a fertilizer is, there are fertilizers that are natural. The natural fertilizer you can get from organic materials like the animal droppies. Okay, like you can get from animal droppies. So we have natural, we have artificial fertilizers. So when we say fertilizers, we get fertilizers. We get some natural one, and we get the artificial one. Artificial ones are the one we manufacture from the lab. So the natural ones are the ones probably from the environment, from charcoal, from droppies, from burning woods, dead woods. You know, the charcoal from the dead woods, they add nutrients to the soil. Animal droppies. Okay, then we have the artificial one. The artificial ones are the one we manufacture, like the NPK fertilizers, like the ammonium sulfate, ammonium nitrate, all these fertilizers. These are artificial ones, the ones we manufacture. So we call them the artificial fertilizers. Okay, so we have the artificial fertilizers, which includes NPK fertilizers. We have the ammonia sulfate, ammonia nitrate. All these are called the artificial fertilizers. But the natural ones are the animal droppies, the feces from animals on the soil, wood, charcoal, charcoal on the soil. When you say charcoal, there are all these things. When you add charcoal to your soil, they will improve the soil condition. Charcoal are the remains from burnt wood. They remain from burnt wood, animal droppies or feces, animal feces. Poop from animals, okay, that's what we mean. Okay, animal droppies. That's what we mean by animal droppies. Okay, all these ones, they are natural fertilizers that automatically you may not be the one that is adding them to the soil, but automatically they help to replenish the soil. They help to replenish the soil. Okay, waste, other some other waste. Okay, if you dump or bury some waste in your farmland, they're going to improve. They're going to improve the soil conditions. Okay, some waste. If you dump some waste, waste. Okay, if you dump some waste on the soil, organic waste on the soil, they're going to like improve the soil condition. All these are called the natural fertilizers. The artificial fertilizers are the one we manufacture. We manufacture like the NPK, We call it NPK, nitrogen, potassium, and phosphorus. That's the meaning of NPK. Nitrogen, N for nitrogen, K for potassium, and P for phosphorus. We have the NPK, we have the ammonium. So I just write the chemical symbol. Ammonium nitrate, nitrate fertilizer, ammonium nitrate. All these are natural. All these are artificial fertilizers. The one we manufacture from the industry or from the laboratory. Then we have the ammonium sulfate. All these are fertilizers that we manufacture that are used to replenish the soil. That are used to replenish ammonium sulfate. All these are fertilizers that are used to replenish the soil or to improve the soil conditions. Okay, so now let's. So we've seen the importance of fertilizer, what fertilizer means, and why it's needed. Now, first of all, what do plants need actually? Let's talk about that. Because all of this we're doing because of crops. We want our crops to do well in the farmland. So what do plants want? What do they need? Or what do plants need? We say plants, they need, usually we know normally what plants need. For photosynthesis, plants, they need carbon dioxide. We know they need carbon dioxide. Okay, the needs of for plants or need of plants. The need of plants. Okay, plants need. So I can simply say plants need. What do plants need? They need carbon dioxide. We know they need carbon dioxide in order to manufacture food. Plants need. Plants need. They need carbon dioxide in order to manufacture food. We know not only do they need carbon dioxide, they also need light. Plants cannot do without light, right? So in order to manufacture food, their own food. So plants, they need light. And so not only do they need carbon dioxide and light only, plants also need what? Okay, we say they also need water. So we write the symbol instead of writing the water, H2O. Plants also need water. So these are specific needs for plants. Why? So that they can continuously manufacture their own food and be able to store food which we eventually get hold of. Now this, apart from all these major things for photosynthesis, plants also need some minerals. Plants also need some minerals which we can enumerate, just mention them. Plants also need some minerals, and the main ones, beyond the ones I'm writing now, they need even more. So I can write their symbols. They need nitrogen. You know, they need nitrogen to make chlorophyll. Plants need nitrogen to manufacture chlorophyll. You know, it is the chlorophyll. Chlorophyll is the green pigment in the plants that helps to trap the sunlight energy. So they need nitrogen to make chlorophyll, and they need nitrogen to make protein. They need nitrogen to manufacture protein. The plants to manufacture protein. If not, if you use only carbon dioxide and water, the plants will only manufacture glucose. So without nitrogen, the food the plant manufacture will only be glucose, which is a carbohydrate, starch, okay? So they need nitrogen. When nitrogen and sulfur react with it, then the plant will be, or nitrogen and other substance, the plant will be able to manufacture protein. So one of the minerals that plants also need to get from the soil is nitrogen. But they don't get nitrogen directly from the soil. They get the compound of nitrogen called nitrate. The nitrogen is not obtained from the soil as nitrogen. They absorb nitrate from the soil, which contain nitrogen, and that nitrogen is what they use. This is the nitrate. There's the chemical symbol of this compound nitrate. So this is what the plants nitrate ion. I put it in form of ion. ion. Okay, they absorb nitrate ion from the soil, and then when it goes into them, they will be able to extract the nitrogen from it for photosynthesis. So one of the minerals the plants need so seriously or profusely is the nitrogen. But I said, despite the fact that they need nitrogen, they don't get nitrogen straight away from the soil. They get what? They get nitrate. They get nitrate from the soil, and it is that nitrate that will go into that will be absorbed by the root hair cells and will help and be broken down, and then they can get nitrogen from it. They can get nitrogen from it. So what they get from the soil is called nitrate, okay, or nitrate ion. That's what they get from the soil, and with the help of bacteria, they will be able to break the nitrate down and extract the hydrogen from it. Is that okay? So that was another mineral they need. So plants not only need carbon dioxide, light, and water to manufacture food, they also need some minerals. Now this mineral will mention one of them, which is the nitrogen. As we said, nitrogen, they use it to make protein food. Nitrogen, they use the nitrogen to make protein food. And they also use it to manufacture chlorophyll. Chlorophyll is the green pigment in plants that help to trap the sunlight energy. So which means, in other words, if the plants do not get enough nitrate from the soil, if you do not replenish your soil so that the plant can get a lot of nitrogen, it will be difficult for the plant to get the chlorophyll that can trap the sunlight energy for manufacturing of food or to even grow properly. So you see, it's very important, super important. Then the next element that the plants need besides nitrogen is the potassium. The next element they need so badly is the potassium. Okay, that's why we always opt for the NPK fertilizers. When we go to the market, we buy the NPK fertilizers. We use it to replenish the soil. Okay, why? Because it contains the nitrogen, the phosphorus, the potassium, and the phosphorus, which the plant needs so dearly. So these three elements, not only these elements are what the plant needs, but these are the main one. Okay, it's not only, okay, you know, when you say something needs something, you mention the main one first. Okay, the one you cannot do without. Okay, these are the main one. Okay, the main one is nitrogen, potassium, and phosphorus. Nitrogen, potassium, and phosphorus. Okay, so they need this potassium. What do plants need potassium for? Why do plants need potassium? What do they use potassium to do? They need potassium to produce protein also. Okay, it's very important for the manufacture of protein. Potassium, plants use it to make protein, and also not only to make protein, to resist diseases. Okay, so plants use this one to make chlorophyll. Let me write what they use each of the elements for, so that it's clearer for you and easier for you to make chlorophyll and protein. That's nitrogen. They use nitrogen to make chlorophyll, chlorophyll, to make chlorophyll, okay, which is the green pigment that is found in the chloroplast that is used for trapping the sunlight energy. To make chlorophyll, and second one, to make what? To make protein. To make the synthesis of protein, to synthesize protein. So they need nitrogen to do this. Now, what do they need potassium for? What do plants need potassium for? Plants need potassium to make protein and also to be able to resist diseases. They need potassium, this one. Number one for potassium is to make protein. To make protein. So potassium is also needed for protein manufacturing. It's needed for the plant to make protein. So, but these are not the only thing. They need the water and carbon dioxide to make protein. Besides water and carbon dioxide, which produces glucose, they need potassium and nitrogen to make the protein part of the food. Okay, so you see, it's very important. So it does two jobs. It's used for two jobs. While you have to buy NPK fertilizer to replenish your soil, is because the NPK fertilizer provides nitrogen to the soil, or in form of nitrate to the soil, and it also provides It also provides potassium to the soil. Remember, potassium is also used for making protein and to help the plant resist disease. Meaning it makes the plant to be able to withstand any disease that is supposed to affect the plant. Resist disease. Meaning it makes it disease resistant. It makes the plant to be disease resistant. Okay, so that's these are the two basic. There may be one or two other functionality of potassium, but these are the two basic ones, okay, for potassium. Now the third one is phosphorus, right? The third one is phosphorus. Now why do plants need phosphorus? What is phosphorus used for? Why is phosphorus being added to the fertilizer ingredient? Why is the phosphorus added to the fertilizer ingredient? And what does phosphorus bring to the table? What does phosphorus offer to the soil? What does phosphorus offer to the soil? Number one, the plant needs phosphorus to help its root to grow. It helps the roots of plants. Okay, phosphorus is used to help the roots of plants. Okay, to help roots of plants to grow, to help roots to grow, to help roots to grow. Okay, so this is one functionality or one function of phosphorus. Why the plants need, because the root needs to grow so that the plant will be firm on the ground, and the plant will be able to be anchored into the soil. Without the root being firmly anchored to the ground, the plants might fall off, might not be able to stand, may not be able to photosynthesize. So that's one function. But another function is that it helps the fruit made by the plants to ripen. You say, oh, this fruit is not ripe yet. Oh, the mango is not ripe yet. Or the whatever fruit it is, the apple is not ripe yet, or whatever fruit it is. It helps fruits to ripen. Okay? To ripen. It helps fruits or any other food from the plants to ripen. Fruits/food of the plant to ripen. To ripe. Okay? To ripen. This one is it help, not to. It helps fruits or food to ripen or to ripe. Okay, so these are the functions. These three elements are very important. So you can see why NPK, and each of them, this phosphorus is P. The symbol is P. You can see it's N for nitrogen, K for phosphorus and for potassium, and P for phosphorus. So NPK. In order, we arrange them like this: first, second, third. So they are all needed in the soil. So now we know their functions. So, and we've defined fertilizers, right? We say fertilizers are contains this one, and not only this one, but made fertilizer contains these elements that we've mentioned. Okay, we begin to give examples of fertilizer that we apply to the soil. We begin to give example. I think we mentioned names: ammonium nitrate already, ammonium sulfate, potassium sulfate, and ammonium phosphate. Ammonium phosphate. So there are a lot. Even the one we mentioned is not all. We can mention more, like potassium, potassium sulfate is also one of them, of the fertilizers that is being applied to help our crops to grow. Okay, one of the fertilizers that is being applied to help our crops to grow. Another one is the ammonia. Okay, we already mentioned the ammonium sulfate. Another one is the ammonium phosphate. Ammonium phosphate. So if you look, ammonia is seriously used for making fertilizer. The ammonia we study in the Haber process, is the second most ammonia, not only ammonium now. Ammonia is the second most manufactured chemical. The first most manufactured chemical is sulfuric acid. sulfuric acid, H2SO4. So ammonia is the second most manufactured one, NH3 is the second most manufactured chemical, and it's used. Why do we need ammonia? It's used for making fertilizers. It is used for making fertilizers. So this ammonia carry out with sulfuric acid to make fertilizer, to make ammonium sulfate, to make ammonium sulfate, to make ammonium sulfate, to make ammonium sulfate. Right? So that's that for that. So we say ammonium, one of the fertilizers, ammonium phosphate is also one of our fertilizers, right? Ammonium phosphate, PO4, ammonium phosphate is one of the fertilizers. So you can see we have NPK, ammonium nitrate, NPK, ammonium nitrate, ammonium sulfate, potassium sulfate, and ammonium phosphate. So these are examples of the artificial fertilizers that we have had. Now let's take a look at examples of reactions, how we make these fertilizers. How do we make fertilizers? How do you manufacture fertilizers? Okay, we can say making of fertilizers. We can look at two ways of making fertilizers. Okay, briefly, before we go to sulfur. Quickly. Okay, making of fertilizers. The making of fertilizers. Two reactions. Let's take a look at two reactions that helps us to manufacture fertilizers in the laboratory or in the industry. Okay, two reactions that enable us to, like I said, ammonia is used in making fertilizers. Ammonia is one of the ingredients for making fertilizers. Okay, ammonia is one of the big ingredient we use in making fertilizers. So ammonia will react with nitric acid to give ammonium nitrate. So you take ammonia, number one. I will just go straight to the reaction. Ammonia is NH3. Okay, NH3. The one we talked about this. If you've not seen ammonia, you can watch our video on the making of ammonia using the Haber process. You can go to our video on the making of ammonia using the Haber process, NH3. Okay, so this ammonia that is manufactured using the Haber process in the industry reacts with nitric acid. Nitric acid is HNO3, nitric acid. You must know all the acid and their chemical symbol. You have to. Okay, if we say hydrochloric acid is HCl. If you say hydrochloric acid is HCl. If you say nitric acid is HNO3, nitric. The 3 is a substrate. Okay, don't write the 3 as if it's on the same level with the letters. It's a substrate. It goes down a little bit. Okay, that's nitric acid. You should know how to write it. Sulfuric acid, this nitric acid, HNO3. And then sulfuric acid, you should know how to write sulfuric acid. Nitric acid helps to get nitrate. Okay, that's the logic. Sulfuric acid helps to get sulfate. Sulfuric acid is H2SO4. H2SO4. That's sulfuric acid. H2SO4. This is for sulfuric acid. The 4 is a small substrate, a little bit down. Okay. Then we have phosphoric acid. Okay. So that's H3PO4. H3 phosphoric acid. H3PO4. So you must know all this acid, how to write the chemical symbol of the compound, of the acid compound. Okay, so you must know how to write all these chemical symbols. So you see, you should know all of this. Okay, so when we talk about them, you should be able to write the symbol. So we say they make one of the methods of making ammonia, especially if you want to make this one, this ammonia, this one we've talked about, this one, ammonium. You know when it's 4, if it's NH4, it's called ammonium. If it's NH3, it's called ammonia. Okay, if it's NH3, it's called ammonia. If it's NH4, it's ammonium. This fertilizer is ammonium nitrate. This one. So it contains nitrogen, hydrogen, nitrogen, oxygen. That's what it contains. This one does not have calcium and phosphorus. Sorry, I said calcium. It does not have potassium and phosphorus. So, but it contains, this fertilizer contains nitrogen, it contains water, it contains hydrogen, it contains oxygen. Okay. So we want to make this one. We want to make this fertilizers. To make it, we react ammonia with nitric acid. Now that's what we're doing here. To make that fertilizer, this is aqueous. You can write the state symbols. This is aqueous, okay, and this is also aqueous. Ammonia is also aqueous. So when you react them together, they will produce ammonium. This hydrogen will combine with this one and become NH4. This hydrogen in nitric acid, this is nitric acid. Nitric, okay, we can change the color. This is nitric acid. Nitric. This is nitric acid. Okay, this is nitric acid. Reacting with ammonia. Reacting with ammonia. Nitric acid react with ammonia, we get ammonium nitrate. Reacting with ammonia, we get ammonium nitrate in the industry. So when we make this chemical reaction to take place, when we provide all the conditions necessary for this reaction to take place, we manufacture ammonium. We manufacture this ammonium nitrate. Ammonium nitrate is NH4. This hydrogen combines with this, it becomes NH4 instead of NH3. It becomes NH4, and then this NO3 also is attached and makes it ammonium nitrate. So this ammonium nitrate is a type of fertilizer. It's a type of fertilizer. So this is one way of manufacturing fertilizer. This is one way of manufacturing fertilizer. This is ammonium nitrate fertilizer. Okay, so in the industry. Another way of manufacturing an inorganic fertilizer is the same ammonia reacting with sulfuric acid. Okay, you know we manufacture ammonia using the Haber process. Number 2 way, we manufacture ammonia. Remember, we manufacture ammonia using the Haber process. Okay, we take ammonia, we get from Haber process. Okay, we react it with sulfuric acid, we get from contact process. We react it with sulfuric acid H2SO4, we get from contact process. When we do this in the industry with all the conditions and all the what you need to speed up the reaction, everything is intact, then you will produce ammonium sulfate. In this case, you will produce what we call the ammonium sulfate. Okay, you can balance the equation if you so wish. So you produce ammonium sulfate. So in doing this, let's see, you produce ammonium. Once you hear ammonium is NH4. Ammonium sulfate. You produce ammonium sulfate, which is also a type of fertilizer. Produce ammonium sulfate. So which means our Haber process product from the Haber process and product from the contact process, both of them can react together to produce ammonium sulfate. Okay, this is also a fertilizer, the artificial fertilizer that is being manufactured. So if I want to balance it, I put 2 here. But because I already put 2 here. Nitrogen is already 2 here, so it must be 2 here. And then this 2 is manufactured, is multiplied with this 4, it becomes 8 hydrogen atom. So here you have 2 times this, you have 6 hydrogen atom here, 2 hydrogen atom, which makes the reactant hydrogen atom to be 8. So you can see this is a balanced equation. So this ammonium sulfate, which is also a type of fertilizer that is being made in the laboratory or in the industry. Okay, so there are many, depending which type of fertilizer you want to produce, but you must always, most of the time, use ammonia. Most of the time, react with maybe phosphoric acid. If you react with phosphoric acid, you get ammonium phosphate, also a type of fertilizer. If you react this acid with ammonia, you get ammonium phosphate. Okay, which is also a type of fertilizer. So These are the things we need to talk about. But these fertilizers that are being manufactured, they help the plants to grow well, to resist diseases, to replenish the soil. Why do we replenish the soil? The soil, when you continuously use the soil will get weared out. It loses its nutrients, can no longer support the plants properly. So you need to replenish the soil by putting fertilizer into the soil, sprinkling fertilizer on the soil, and helping the plants to grow properly. Now, beside all this good news, fertilizer have added to yield, because without fertilizer, we'll run out of food. We'll not be able to produce food that will cater for the whole human race. Okay, because we have almost about 8 billion people right now on the planet. So we'll not be able to manufacture sufficient food that will take care of the about 8 billion people we have on the planet. So to keep the soil to be replenished, we add fertilizers to the soil so that the plants we give much more yield. It's not as if the plant may not grow, but they will not give much more yield. They will give you produce big hectares of land, you only get very little produce from the farm. Now, these are the good news of fertilizers, but what is the not so good news? Fertilizers, when you plant them near the river, when you apply them, your farmland has a river around it. When you put them near the river, they be washed to the river. That's the bad news, the disadvantage. They wash to the river sometimes when rain falls. The fertilizer you apply to your soil, they be washed to the river. And when they wash to the river, they help the plants in the river to grow. And then, which are called the algae. You know algae? Which are called the algae. The algae are like the mucus. They cover the top of the entire river, so they don't let oxygen to go in. They don't let oxygen to go into the river. So when the plants don't have enough oxygen, the animals, like the fish, the aquatic animals in the fish, like the fish and every other aquatic animal in the river, they die. They die. This is the disadvantage of fertilizers. When rain falls, they wash. If there's river near your farmland, they be washed to the river. And when they wash to the river, they help the small plants that are in the water to grow and spread and cover the top surface of the river. The whole top surface will be green, will be covered with greenish thing called the algae. This algae prevent the entrance of oxygen from the air into the river. You know, oxygen also goes into the river. So the algae prevent the oxygen to enter the river. The fish, they need the oxygen to survive. And every other aquatic organisms, they need the oxygen to survive. So when they don't get this oxygen, they die. So all the aquatic animal dies. So you're trying to have crops, the animals, they die. We need both plants and animals to survive. They be used as food. So this is what you should be careful about. If your land has a river near it, you should know where you apply fertilizer. Don't apply fertilizer on the part of the land that is so close to the river, okay, in order to prevent these problems. Also, another problem is that, apart from covering there's this one problem one. Okay, the one disadvantage of this fertilizer, it causes algae to grow in the river and cover the river, so oxygen cannot go into the river and the plants they die. Another problem is that it goes into some river, the fertilizer is being washed into some river, and we fetch the water to come and use. We fetch the water to consume. And then when we drink this type of water, it causes sickness to our body. So this is another disadvantage from it. It causes sickness to us when we drink the water that has been polluted by fertilizer. So we drink, especially children, okay, especially children, it causes a lot of health problems to them, and even cause death to happen to children. Okay, so sickness when we drink any water that contains fertilizers, or that is not properly purified, that contains fertilizer and is not properly purified, and we consume such water. You remember the water we use in our home is being pumped from the river by the water companies. They be pumped and purified from the river. So we hope they purify it properly. So if they don't purify it properly and we consume this water, that's why some people don't drink this type of water. They drink the treated water. So when you drink this type of water, the danger is that it can cause children to be sick, and it can even cause death if there is not. So this is all about fertilizers. So we go to the second part of this class, which is sulfur. So now we look at sulfur. We've elucidated what we need to know about fertilizers for the Cambridge exam. Now let's take a look at sulfur and sulfur dioxide. Okay, we're going to treat them together. They're together, sulfur and sulfur dioxide. We treat them together. Okay. Now sulfur is found in the soil. Okay, but not alone most of the time. It's found with other compounds. not alone, it's found with other compound. Okay, sulfur is not alone, it's found with other compound, but we extract it from other compound. We even get it from this petroleum product like natural gas. We get it from the natural gas, okay, and so on and so forth. Okay, but let's quickly take a look at what that is. Where do we find sulfur? Remember, first of all, you know sulfur is a non-metal, right? We know that sulfur, so I just write S for sulfur, okay, as the symbol for sulfur. It's a non-metal. We have to establish it's not a metal. It's not a metal, so it's a non-metal. We already know this, right? Because most people confuse sulfur for metal. Most people confuse sulfur for metal, right? Okay, and then we say it's a non-metal and it's quite very common, right? On the earth crust, it's very common. We have a lot of sulfur everywhere. It's very common on the earth crust. It's found as an element in the underground beds in several countries. You find it as an element, exists as an element in underground belt in many countries. Example of this country includes Mexico, where you can find sulfur, okay, in underground bed. Mexico, Poland, USA, you can find sulfur in US, United States of America. Okay? You can also find it around the rims of volcano. Anywhere you see volcano taking place, you can find sulfur. Okay, around the rims of volcano. So many is not only found only in countries like Mexico, Poland, not only in the countries like Mexico, Poland, and USA. It's also found around where like Iceland or any place where you find a rim of a volcano. Okay, you can find sulfur in bed underground, like the bed we used to sleep in bed underground. Okay, you can find it in bed underground. So not only in this country you find them, you can find them anywhere you find a volcano. It occurs as a compound also, so not only as element. This one I've mentioned is the occurrence as element underground. Okay, sulfur can also occur as a compound. Okay, is also found in compounds, and this is where you find it in the natural gas. Sulfur also occur in compounds. So compound we abbreviate. We just write compounds like this. It occurs in compounds. Okay. Like as a good example is like metal ore. Although it's not a metal, it's found in metal ore. Okay, it's found in metal like lead ore. The ore of lead. You can find sulfur in the ore of lead. Metal ore. So when you extract lead, the ore of lead, you can find sulfur. Like for example, you say galena, which is lead 2 sulfide. So you can find sulfur in this compound. Lead 2 sulfide, PbS. This is lead. This is the symbol for lead, and then PbS. This is lead 2 sulfide. The other name for lead 2 sulfide is called galena. Galena. This is the other name for this compound, lead 2 sulfide. This is the other name, galena. Okay, so lead 2 sulfide. So you see, this is a compound of lead. Okay, a metal ore. When you can extract the sulfur away from this compound. Okay, by reacting this maybe probably with oxygen, by burning this in oxygen also, depending, or with water and so on and so forth. So that's it. That's the sulfur. We say sulfur compounds. They also occur naturally in the fossil fuel, like in the coal. You know fossil fuel, right? You can find them sulfur compounds in fossil fuel. Sulfur compounds in fossil fuel. You can find sulfur compound in fossil fuel. Okay. A good example of fossil fuel, coal. You know coal, right? Coal, natural gas. Example is coal. So many, if you extract coal, you'll find sulfur. You'll find sulfur, right? Natural gas, like methane, you find sulfur in the compound. Okay, natural gas, and petroleum. Petroleum is oil. Petroleum. So if any of these you extract or you drill, you're going to find petroleum. Any of these you do, you're going to find sulfur. You're going to find sulfur. Is that okay? The purification is another thing we'll talk about later on. But so far, this is where three places we've mentioned where you can find sulfur. First is in the elements or on the bed, on the ground. In some countries like Mexico, Poland, USA, they are found on the bed as elements, as just sulfur elements. Then you will say you can also find sulfur in compounds, in some other compounds like the metal ore. A good example is lead 2 sulfide. A good example is lead 2 sulfide, which is another name is called galena. Okay, we say you can also find sulfur compounds in fossil fuel like coal, natural gas, and petroleum. Okay, now let's go to extraction of sulfur. How do we extract sulfur? Extracting sulfur. How do we extract sulfur? Extraction of sulfur. Extraction of sulfur. So how do we extract sulfur? How do we get sulfur that we use it? How do we get it? Remember, sulfur is used for manufacturing sulfuric acid, which is the most manufactured element or compound or substance on earth. So this is one big use of sulfur. So how do we, first of all, let's talk from oil and gas. From oil and gas perspective, how we get it from oil and gas, what do we do, and how do we get sulfur from oil and gas? So oil and gas, what do we do to get sulfur from this process? From the third one, this process I mentioned, the third one, the third way, because here is from where you get the oil and gas system, ecosystem. Okay, most sulfur is now obtained from the sulfur compounds from the petroleum and natural gas that we've mentioned already. Now these compounds, they remove to help reduce the air pollution. We have to remove these compounds in order to reduce the air pollution, because if sulfur dioxide goes into the air, it pollutes the air, causes acidic rain, and causes other issues to our environment, right? And pollutes our environment. Natural gas is mainly methane. If we are looking at the case of natural gas, we say this natural gas, oil and gas, natural gas is mainly methane in this regard. Okay, methane is CH4. If you write the chemical symbol CH4, this is methane. Okay, organic chemistry. I'm very sure some of us we've done organic chemistry. If not, we will refer you to this. Okay. Okay, so we say if you extract methane from natural gas, you'll be able to get about at least 30% of sulfur compound. 30% of a sulfur compound, like hydrogen sulfide. You can get about 30% of hydrogen sulfide. Hydrogen sulfide is in this. This is the formula H2S, hydrogen sulfide. So if you extract methane, you'll be able to get about 30% of hydrogen sulfide, which is a compound that contains not only lead sulfide that contains, that's for metal ore, but through oil and gas we get hydrogen sulfide. Is that okay? And which contains a great deal of sulfur. So how do we now get sulfur out? How do we get sulfur out from the hydrogen sulfide we get from natural gas? How do we get the sulfur out? What do we do to get the sulfur? Because we want the sulfur. To get the sulfur, we react this hydrogen sulfide that we get from the natural gas. This hydrogen sulfide that we get from the natural gas, we react it with what? We react it with oxygen. We burn it in air. We burn it with air. So whenever we say we burn something in air, it means we react it with oxygen. This is a gas. Oxygen is a gas. Okay, the hydrogen sulfide in this regard is also a gas. From the oil and gas, the hydrogen sulfide is also a gas. Okay, it's not a solid. So when you react this, you'll be able to produce water. You'll be able to produce water because this hydrogen we react with the oxygen to produce water. You'll be able to produce water, H2O. You can balance it, as the case may be. You'll be able to produce water, and you will now be able to produce sulfur. You'll also be able to produce sulfur separately. You'll be able to produce sulfur. Remember, we are looking for how to produce sulfur, how we get sulfur from the oil and gas. In oil and gas, during the extraction of oil and gas, one of the compounds that is produced is hydrogen sulfide. Hydrogen sulfide. Now, once we get this hydrogen sulfide, to get the sulfur out, sulfur is a solid, okay? The state symbol. Water is a liquid in this regard. Water is a liquid if we are to put the state symbols. Okay, so once we get the hydrogen sulfide from the natural oil and gas, then we react with it, oxygen, or we burn it in air. We produce water and sulfur. We can balance this. If you want to balance this, then probably you can look which is which. If I put 2 here, because if I put 2 here, where else can I put 2? Meaning I can put 2 here. So that sulfur will be 2 atoms on the left. Hydrogen is now 4. Hydrogen is still is just 2 here, so we can still put 2 here, so that we have 4 atoms of hydrogen on the right and 4 atoms of hydrogen on the left. We have 2 atoms of sulfur on the left. We have 2 atoms of sulfur on the right. We have 2 atoms of oxygen on the left. We have, because of these 2, we have 2 atoms of oxygen on the right. So you can see the reactant and the products are balanced. So this is it. This is one way of producing sulfur from the petroleum system, from the petroleum. Now, from sulfur bed, you know, we say sulfurs, they're found as elements in the sulfur bed underground. So from the sulfur bed, about 5% of the sulfur we use come from the underground sulfur bed. Superheated water is pumped down to melt the sulfur and carry it. You know, it's a solid, so we pump very hot water to it to melt it and to bring it to the surface. It meant the melting point of sulfur melts at 115 degrees. So you must make your water superheated water. If it's just boiling at 100, it may not be able to melt the sulfur at 115, because sulfur will start to melt at 115 degrees. Okay, the sulfur underground, so we call it the bed, sulfur bed. Sulfur underground. This is the ground. Sulfur is this side. Okay, sulfur bed. To get sulfur from as element underground, it's a solid underground. So to get it, we pump very superheated water, not just water, not just heated water, superheated water. Superheated water whose temperature is way above 100 degrees Celsius to melt the sulfur underground, and then you'll be able to draw it out. So this sulfur, the melting point is 115 degree melting point. The melting point, MP, melting point of sulfur, please take note. Melting point of sulfur is 105 degrees. So you need a superheated water to be able to bring this out for you. You need a superheated water to reach this temperature and be able to melt the sulfur and be able to bring, you'll be able to draw the sulfur out into the surface. Now let's take a look at properties of sulfur and uses of sulfur before we go to sulfur dioxide. Let's go to the properties. Okay, we'll be fast with the properties. We just highlight them. We write only the keyword. Properties of sulfur. What are the properties of sulfur? And then we now look at the uses of sulfur. Okay, I know I've missed arrow here. Properties of sulfur. Okay, so properties of sulfur. One is that it's brittle yellow solid. It's brittle. And the color is what? Yellow. And it's a solid substance. Brittle, meaning not so hard. Even though it's a solid, brittle, yellow, solid. Yellow solid. So we need to take note of this. The color of sulfur and the hardness of sulfur. That's the first one, the first property. Sulfur is a brittle yellow solid. Okay? Now let's take a look at the second property of sulfur. We say it has two different forms, or allotropes. You know, allotropes means the forms of sulfur. We say allotropes of carbon. We measure diamond and graphite for carbon as elements, right? The sulfur also exists in allotropy. the form of the two forms of sulfur. It has two allotropes, meaning it has two forms. It exists in two different forms, two allotropes. There are two allotropes. Means sulfur exists in two different forms. Two allotropes of sulfur. What are they? What are the names? It exists as rhobic sulfur, and it also exists as monoclinic sulfur. So these are the allotropes. Rhobic, like rhombus, spelling of rhombus. It exists as rhombic sulfur. The shape would be a solid that looks like a rhombus. Okay, the shape would be a yellow, complete yellow color. Okay, maybe in this regard, I should use a yellow color. The shape would be something like this. Because it's yellow, sulfur is yellow color. And this is the shape it will have. Aerobic. This is aerobic. Okay, this will be the color of the substance, of the sulfur. So it exists like this. Aerobic. It exists like this. I'm only trying to shade, supposed to shade it, not to color it. Okay, it exists. Okay, this is one form of allotropes of sulfur. It exists as rhobic sulfur. The second one, when you pour hot water, you know, we mentioned that you pour a lot of hot water, and then it becomes like something like melted, like just melted and diluted. The yellowiness is a bit reduced. It becomes like creamy color, and that is called monoclinic sulfur. That's called the monoclinic sulfur. I wish I can get that color a bit fainted or something close to creamy. Something close to a creamy color. Okay, so let's something like this. So the second allotropes will be monoclinic. Monoclinic sulfur. Okay, this one, monoclinic sulfur, this is the second allotrope. This sulfur is no longer super solid, is melted or is melting. You just have things like some parts here still remaining. Then here is melted. You have small part here, small part here. So it's melted somehow, not so remaining, something like this. Okay, and the color is a bit faded, not super yellow. Because this is called monoclinic sulfur. Monoclinic sulfur. So sulfur exists in two different allotropes. It has two different forms. It has two different forms. We have rhobic sulfur. We have the rhobic sulfur. Rhobic sulfur. We have the rhobic sulfur and the monoclinic sulfur. So please take note, sulfur has two allotropes or two forms, rhobic sulfur and monoclinic sulfur. So I just marked these two. No need to write sulfur a second time. Okay, so this is the second property. Now let's go to the third properties of sulfur. What's the third property of sulfur? Sulfur is, we say it has a quite low melting point. Okay, we can just say low melting point, right? Low melting point. You know, some substance, their melting point that are solid gets up to thousands of numbers, right? So for this one to just be 115, it's still considered, for solid to melt at 115 degree, it's still considered a low melting point, right? Sulfur has a low melting point of 115 degree Celsius. So it's considered low somehow. Okay, so that's another property. Now let's go to another property of sulfur. We say although non-metals, it does not conduct electricity. So Does it conduct electricity? Does it? It does not. Okay? It's a non-metal. Like every other non-metal, sulfur does not. Does not, or does it conduct electricity? You know, metals, they do conduct electricity. Okay? Does not conduct electricity. So it's a property of sulfur. Sulfur is not used as conductor. Okay, it's not used as conductor to conduct electricity. So if you're thinking of an element to use to build a circuit to conduct electricity, sulfur is not one of such elements. Sulfur is not one of such elements to conduct electricity for you. So it does not conduct electricity. So let's go to property 5. We say sulfur. It's we say it does not conduct electricity, right? Then another one is that, like most non-metal, it's also insoluble in water. Does not dissolve in water. Insoluble in water. So I can just write the word insoluble. Okay, I can just write the word insoluble. Sulfur, like most of the non-metal, they are insoluble in water. They do not dissolve completely in water. It reacts with metals to form sulfide and other properties. It will react with metals to form sulfide. React with metals to form sulfide. Like lead, we write lead 2 sulfide today. Forgot? Lead is a metal. React with metals to form sulfide. We've given you an example previously. Lead react with sulfur, for example, lead plus sulfur to form lead 2 sulfide. Right? React with metal to form sulfide. Produce lead 2 sulfide. Okay? And this is an example of what we are saying. Okay? So these are with so many. They are with iron to form iron 2 sulfide. We say they are with metals, not only lead, iron to form iron 2 sulfide, and so on and so forth. It bonds in oxygen to form sulfur dioxide. This is very important. This is where we are going now. This 7th property is what is leading us to sulfur dioxide. It bonds in oxygen. To form sulfur dioxide. It bonds, meaning in air. Okay? Oxygen in this regard we're referring to air. It bonds in oxygen. I'll abbreviate oxygen. Okay, no need. That's right. It bonds in oxygen to make what? To produce sulfur dioxide. To produce sulfur dioxide. To produce sulfur. Can I write in there? Okay. Sulfur. Produce sulfur dioxide. So this is going to lead us to sulfur dioxide. It's this next subheading we have in order to call it a day. Okay. So to produce sulfur dioxide, SO2. It bonds in air to produce SO2. We can write the equation. Right? To produce SO2. Meaning sulfur reacts. Sulfur is a solid. Let's take a different color. Sulfur is a solid. Right? It's a solid. It bonds in air or oxygen. Oxygen is a gas. React with oxygen, which is a gas. To produce what? To produce sulfur dioxide. Okay? And which is also a gas. Produce sulfur dioxide, which is also a gas. This sulfur dioxide is used in making sulfuric acid, H2SO4. It's used in making H2SO4. You're going to see that in our next video. You're going to see that on our next video. Okay, now let's take a look at uses of sulfur quickly. Uses. What do we use sulfur for? Why do we need sulfur? What benefit does it have? What value does it have to us, to our lives? How does it improve our lives? Okay? How does it improve our life? Why is sulfur important? What do we need it for? So let's quickly run through this. Okay? We write only the keywords. Uses of sulfur. What do we use sulfur for? What's the benefit of sulfur? How does it play a significant role in our life? And why do we need it? What do we need it for? Quickly, let's say. One, most sulfur is used to make sulfuric acid, see? Which I've already told you. Sulfur for making sulfuric acid. So I just making sulfuric acid. We need the sulfur to make sulfuric acid. Not only sulfuric acid, you need it to make oleum. Okay, when we study the sulfuric acid, you see how oleum is being manufactured before the sulfuric acid eventually. So number one use of sulfur is that we use it to manufacture sulfuric acid. Another use of sulfur is that it's added to rubber, like the car tire rubber, to toughen it. And this process is called vulcanizing the rubber. So we can simply say it's used for vulcanizing the rubber. For vulcanizing rubber. For making the rubber to be tougher so that it can form tires. Vulcanizing is used for vulcanizing rubbers. To make it tougher so that it can become car tires. Vulcanizing rubbers. Okay? The rubber we get from the farm, from the plant, we toughen it, we make it tougher by adding sulfur to it. Okay? So we say sulfur is used for vulcanizing rubber to make it tougher and make it ready to be used as car tires. Sulfur is also used for making drugs, pesticide, dye, matches, paper, so on and so forth. Okay? Making drugs, medicine. Okay? Sulfur is used for making drugs. Not only drugs, pesticides for killing pests in our farmland. Drugs, pesticides, used for making drugs, used for making pesticide, and used for making paper, dye, matches, the matchstick. Sulfur is used for making matches. Okay, matches. The matchstick you use for lighting up things. Matches, dyes, for dyeing your hair, for dyeing your clothes, and so on and so forth. Papers, the paper you're writing on. Okay, sulfur is added to it, to the wood, to make it smoother and better, and so on and so forth. Okay, so another use, which other use do we put sulfur into? Making cosmetics, shampoo, your shampoo, your hair cream, your lotion. Okay, cosmetic. So I just write cosmetic. So I don't have to write everything. Cosmetic. Sulfur is used for making cosmetics. Like your lotion, your body cream, your shampoo, your hair cream, whatever you want to call it. So simply we just say it's used for making cosmetic. Okay, sulfur is used. So you can see it's super important. Sulfur, all your body lotion, sulfur is used in manufacturing them. Now also we say it can be added to cement to make sulfur concrete. To make it is to make a sulfur concrete. So I can write for making concrete. Okay, to make a sulfur concrete. You add it to cement to make a sulfur concrete. Okay, and so on and so forth. So this is the end of sulfur. Now we are in the last part of today's class, which is called sulfur dioxide. So I will just write the symbol SO2. Okay, I will just write the chemical symbol SO2, sulfur dioxide. Okay, now what is sulfur dioxide, and why do we need sulfur dioxide? We need sulfur dioxide so that we can manufacture sulfuric acid. Sulfur dioxide is a gas, and if it's formed when sulfur burns in air, which we have already explained in the property when we describe the properties of sulfur. Now it is a colorless gas, and it's heavier than air. It's denser than the air. So sulfur dioxide is denser than the air with a very strong and choky smell. It has a very choky smell. So we just describe it as sulfur dioxide. It has a choky smell, a pungent smell, choky smell, and it's denser than air, and it's a colorless gas anyway. And like most non-metal oxides, it's an acidic oxide. Okay, this is very important. This is an acidic oxide. Okay, you know, non-metal oxide, they are acidic oxide. Metal oxide, they are basic oxide. If you study oxides in the previous classes or previous level. So this sulfur, SO2, CO2, they are all NO2, all these are acidic oxides. Okay, what it means, they will react with this to form acid. Okay, so they are acidic oxide, they are acidic oxides, they are acidic oxide. So that is very important. We need to take note that sulfur dioxide is an acidic oxide. Not only sulfur dioxide, every other non-metal oxide, they form acidic oxide. Okay, and it will react with water to form what? To form sulfurous acid. Not sulfuric acid, sulfurous. This sulfur dioxide will react with water to form sulfurous acid. Sulfur dioxide react with water to form sulfurous acid. To form sulfurous acid. H2SO3. H2 instead of SO4. Sulfuric acid is H2SO4, but this H2SO3. This is called sulfurous acid. So whenever they react with water, they form sulfurous acid. Is that okay? They form sulfurous acid. So this is it, which is also aqueous. And this will break down easily to form water and sulfur again, easily. It doesn't stay long. Like you're making it is breaking down to form the reactant. The product is breaking down to form the reactant. It breaks down easily to get the byproduct. So that's why we don't normally use it. Now it acts as a bleach when it's damp in solution. Sulfur dioxide acts as bleach. So as bleach when it's damp in solution, it can help to bleach substances. Okay, but it has to be damp. There's a condition that it has to be damp in solution, and then it will be able to act as a bleach. Why is this so? Because it removes the color from any color compound. It will remove color from any color compound. That's why it's acting as a bleach. Okay, it will help to remove color from any color compound. So when it's damp, only when it's damp in solution. Okay. Another thing is that it is used as, it can kill bacteria. Sulfur dioxide kill bacteria. Okay, it kills bacteria. So meaning it can be used as a preservative, kill bacteria, right? It kills bacteria. So we can use it for or as preservative, depending how well it's being used. Okay. Sulfur dioxide is also, the bad news is that it's a pollutant, you know, right? It causes acidic rain. SO2 gas, when you leave it to escape to the atmosphere, it pollutes the environment. You get it, you know, you can get it from coal and petroleum. They contain sulfur compounds. So even after you've refined or you have produced or you've drained this petroleum, after the petroleum is treated to remove them, then this sulfur compound, sulfur dioxide, are still inherent and may cause a bit of pollution to the environment. Some coals, they contain high percentage of sulfur. And when these fuels are burned in power station, the factory, they produce what? They react, the sulfur reacts with oxygen, with air, to produce sulfur dioxide. This sulfur dioxide, they escape to the atmosphere. When they do, they become in-house gas that deplete the ozone layer and causes a lot of problem to our environment. Okay, so these are some of it, and it also causes acidic rain because when the pure rain that is coming, when it reacts with it, when the rain reacts with it, it causes this acidic rain. When the rain reacts with sulfur dioxide, it causes this acidic rain. Okay, which is very harmful to us, which is not good for us. Now let's talk about the uses of sulfur dioxide. What do we use it for? Obviously, we know it's used for manufacturing. We know it's used for manufacturing. Let's change the color. Uses. Uses of SO2, sulfur dioxide. What do we use it for? For manufacturing sulfuric acid. It's used for manufacturing sulfuric acid. So one is for making sulfuric acid. So I'll just write the formula H2SO4. It's used for making H2SO4. This is what we call sulfuric acid. It's used for making H2SO4. It's one of the ingredients that is used in making H2SO4. This is our next class. We're going to treat the making of H2SO4. Just like we make ammonia, we want to treat how to make this one. So this is the first use of sulfur. Manufacture of sulfuric acid. It's also used to bleach wool, silk, and wood pulps for making paper. So in summary, we say for bleaching colors. Okay, for bleaching color compounds. To make bleach. For bleaching wool, paper, and so on and so forth. Is that okay? So that's one use of sulfur dioxide, used for making bleach. Okay, another use is it's used as a food preservative. I mentioned this. Used as food preservative to preserve because it can kill bacteria, so it's easy to preserve food. So it's used for making preservative. Food preservative. To preserve the food for later use. So that we can even export preservative. So that we can export the food, But preservatives are chemicals. When they are too much, they cause cancer, they cause so many problems. So that's why it's good to eat natural food, like the ones we find in Africa. It's good to eat natural food from the farm. Okay. So this is what we have for our today's class. Okay. So we thank you for joining us.